Hi guys, so welcome to the second part of 3.10, which is trig equations and inequalities. So we're going to kind of just pick up where we left off on solving an equation with a multiple angle. So it is on example number 8, so make sure you're there. So a multiple angle just means whatever I have inside here is not just x, but maybe it's x times 2 or x divided by 3. And the easiest way to think about this is think about, well, where does tangent of x equal square root of 3? Well, if we use our unit circle, that's going to happen when I have the coordinates 1/2 square root of 3 over 2. Remember, tangent is sine over cosine. And then also at 4 pi over 3, because both of them would be negative there. And if I divide a negative by a negative, I get a positive. So those two angles, this is pi over 3, and this is 4 pi over 3. Okay, so if I'm going to find what the x value will equal, I'm just going to take 2x, which is what's inside my tangent function, and set it equal to pi over 3 and solve for x. So I'd divide both sides by 2, and I would get pi over 6 as my first solution. Same thing for this one. Divide by 2, I get 4 pi over 6, but I can simplify that to 2 pi over 3. Now, one thing we have to keep in mind whenever we're doing double angles is notice that both of these pi over 6 and 2 pi over 3 both happen in the top of the circle because you're essentially taking your angle and dividing it by 2. So we have to also think about coterminal angles, meaning if I go around the circle again, what that angle will be. Well, I know that a full circle is 2 pi, so I could add 2 pi to that pi over 3 that was my original angle, and I get 7 pi over 3. I could do the same thing for 4 pi over 3. Again, coterminal angle, just add 2 pi, and I get 10 pi over 3. Okay, now remember those are not my final answers, so I still need to say 2x would then equal 7 pi over 3. Divide by 2, and I get 7 pi over 6. And then 2x equals 10 pi over 3. Divide by 2, I get 10 pi over 6, which is equal to 5 pi over 3. So there's actually going to be 4 answers here, and you want to go around the circle more than once because all of these final answers, pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3, all fall in my interval from 0 to 2 pi. Okay? All right, let's look at the next one. Sine of x over 3 equals 1/2. So we're thinking, where does sine equal 1/2? Well, it's going to happen at pi over 6, big X, little y, and also at 5 pi over 6. Okay? So then we're going to say, well, those are not my final answers. I'm going to set what's inside the sign equal to that. So I have x divided by 3 equals pi over 6, and x divided by 3 equals 5 pi over 6. To get x by itself, I can multiply both sides by 3, so I get 3 pi over 6, which simplifies to pi over 2. Multiply both sides by 3, I get 15 pi over 6, which if I simplify, I can divide the top and bottom by 3, and I get 5 pi over 2. Well, 5 pi over 2 is actually too big. It's not on my unit circle from 0 to 2 pi, so I don't care about that solution. If my interval was bigger, then I would. So my only solution here that's in my interval is going to be pi over 2. I don't need to worry about going around the circle again because if I do another lap, it's still going to be too big. So I've already hit kind of that maximum point there. Again, I don't include that 5 pi over 2 because that's not in the interval 0 to 2 pi. So big idea is if I have like a 2x inside, then you probably will have to go around more than once. If you have x divided by 3, which means when I multiply, the angle will get bigger, then I probably don't need to do that. All right, let's look at a couple inequalities now. The first one's going to be the hardest one because we're not going to have a calculator, and then the other ones we'll just use our calculator to solve. So this one says cosine of 2x is greater than 0. So how I would think about this is finding out where does cosine of 2x equal 0. Those are going to be my critical points. Well, cosine equals 0 at pi over 2 and 3 pi over 2. Divide by 2, I get pi over 4. We also set at the bottom, so 2x equals 3 pi over 2. Divide by 2, I get 3 pi over 4. Now let's go around the circle again. So if I take pi over 2, which is at the top, and I add 2 pi, that would be like doing pi over 2 plus 4 pi over 2. Which gives me 5 pi over 2. Divide by 2, I get 5 pi over 4. And then if I take 3 pi over 2, and I go around the circle again, which is adding 2 pi, I get 7 pi over 2. So set that equal to 2x because that's what's inside my cosine. And if I divide by 2, I get 7 pi over 4. So those are my critical values on the interval 0 to 2 pi. And then we're just going to kind of go back to what we've done with polynomials. So I have 0 and 2 pi because it doesn't go on forever. Then I have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay? So I know that if I plug in a value, I can figure out what that will be at each of those endpoints, okay, and then kind of evaluate from there. So let's say that I maybe plugged in, maybe if I plugged in pi over 2, we know that pi over 2 would fall in this interval here from pi over 4 to 3 pi over 4. So if I plug in pi over 2 to my original function, I get, the 2's would cancel, so I get cosine of pi, which is equal to -1. So that means in this interval right here, it's going to be negative. This would be positive, positive, negative, positive, because it's going to alternate. Now we want to think about, we know at pi over 4 that it's going to be equal to 0. Same thing at 0 to be equal to 0. So these are going to be parentheses, not brackets. And I want when it's greater than 0. So it'll be from 0 to pi over 4, from 3 pi over 4 to 5 pi over 4, and then from 7 pi over 4 to 2 pi. Okay? So that's kind of all you're doing there is figure out your critical points and then go back to what we've done with polynomials. All right, now in example 11, it gets a little bit more complicated. We're not going to be able to solve this by hand. We're going to have to use our calculator. So in my y equals, I'm going to type in sine of alpha y equals, is how you can get a fraction. Or actually, I don't need a fraction yet, I lied. X minus pi over 3. And then in my second one, I'm just going to do sine of x. So, because I'm trying to find when the blue is going to be greater than the red. Now, for my window, I want from the interval 0 to 2 pi. So I'm going to make this 0 to 2 pi. And then I know my sine of x is only going to go from -1 to 1. So I'll just make this maybe -2 to 3, or 2 is fine, just so I can kind of see it. Okay, so one problem that I have right here, right now I'm in degree mode, so it's getting really stretched out. So if I go and change my mode into radian mode, because that's what I want in Precalc, if I go to graph, it'll look a lot better. So we want to know when sine of x minus pi over 3, which is the blue graph, okay, is greater than the red graph. So hopefully you can visualize that it's going to be this little section right here, but I need to find those intersection points. So to do that, I'm going to go to second trace, then go to intersect. And then this point right here is about 2.047. Okay. Oh, it's not. I haven't pressed enter yet. 2.094. And then I'm going to do it again and find the other intersection point. So we had 2.094 for the first x value. And for the second one, it's about 5.236. So from when x is 2, that whole blue section is above, which means it's greater than. So therefore, it's going to be from 2.094 to 5.236. And again, I got that just by using my calculator and finding those intersection points. Okay. All right, let's do, that one's pretty much the exact same, find the intersection points. Let's go ahead and just look at one example where there's kind of words going on. So this says when breathing, a normal cycle takes place about every 5 seconds. Velocity of airflow is measured in liters per second. And we want to find out when it's above 0.3. Okay, so I'm going to type in my calculator this y equals. I'm going to make y2 equal to 0.3 because I want to find when it's above that. And then I'm going to type in my function here, and hopefully you're doing this in your calculator as well. 0.6 sine 2 pi over 5x. X. And then I'm going to graph. And so I want to find for one cycle of breathing, which is one period, when it's greater than this red line. So I just essentially need to find for one period, which is from here to here, where this will be greater. So in this little section right here. So if I can find these intersection points, then I'll be good to go. So the biggest one is 2.083, and then I can do it one more time to find the first value, which gives me, I guess, 0.417. So from 0.417 seconds to 2.083 seconds, that is when it's greater than 0.3. So in context, from those seconds, from 0.417 to 2.083, that's when my velocity of airflow is greater than 0.3. Okay, that's essentially what you're saying in the context of the scenario. So a lot of this is just kind of review of the first part of 3.10, but then it's also adding, can we use our calculator to find those intersection points to find when it's greater than or less than. Have a great rest of your day.